What's the best way to avoid surface artifacts and edge smoothening?
This is today's third question. This question led to a lot of discussion this month with over 40 replies, so we really wanted to address it here. Gabriel asked about a phenomenon when experimenting with his newly bought scanner. He created his own experimental model and performed a test scan. Gabriel discovered when scanning abutment models in vitro, margins did not appear in their original form in the final scan data. He noticed that the margin being transformed into round shape, and he wanted to know why this was happening and how it could be prevented. He also asked if there were any specific settings that would be help with this. This is a very good question. Let's summarize what was asked first. He wanted to know where to mark the finish line when you get rounded margin, why these artifacts on the surface were happening, and lastly, if we could share an example of a high magnified image of the shoulder or chamfer margin. Chen, do you have any input on this?
Yes, sometimes I feel as if the margin resolution is low, especially when the margins are thick.
Oh, I see. Then let's take a closer look. Why does this phenomenon occur? Let's watch our solution video together.
Gabriele's own experimental mode, what happened there? To summarize the problem, the scanned image of the sharp margin data was altered into a rounded shape. When we use a scanner, our purpose may be to obtain data as precise to the actual shape as possible. As Gabriele asked, if the scanner cannot capture the margin as it is, we need to know exactly why this phenomenon occurs. When I first saw the picture he posted, I assumed that post-processing only occurred at the margins in the software, similar to the die trimming process of the stone model. For example, like the overbite phenomenon we mentioned in the March session, I wondered if there was some automatic processing in the software to clarify margins. If that is the reason, you might get a rounded margin, even when you have obtained sufficient margin data. However, I did not think that the scanner would specifically recognize the margin area and perform post-processing automatically. In particular, when looking at actual patient cases, such rounding was not observed. So what was happening in Gabriele's experiment? So we asked the expert that we thought would know this best, Dr. Kim, of Ask Dr. Kim Anything. His answer was very clear. Scanned data actually looks like that when it is enlarged, so there is nothing to be concerned about. When I heard this for the first time, I didn't understand what he meant. He explained this using an example where he draw a circle on large grid paper. He told me that, in the exact same way, when scan data is extremely enlarged, the margin edges are not expressed as right angles, but instead appear round. Honestly, I was not quite sure what he meant, but he said this was a common sense, so I was too embarrassed to ask for clarification. I decided to research this answer myself. I was able to find one research article that explained this phenomenon. Let's see what it said. They start by explaining the concept of mesh density, which is essentially the resolution of the scan data. If we use the density as seen on the right side, we will get much detailed resolution in our scans. However, the file size would be exponentially larger, and more importantly, this would not affect the clinical acceptance range. It means if you set the mesh density high in the final scan data, the results can be made to look sharper. However, because the difference has little effect on the clinical outcome of the final prosthesis, the scan software is, by default, set to display the scan data in medium resolution. And you can see that the margin area is manually prepared by hand, so it has a more complex geography, which would not be precisely reflected in the scan data under the default resolution setting. A high-density mesh is needed to precisely display the emergence profile, but a low density would not pick on the complex curvature, therefore it results in the smoothening of margin areas. The scanner is able to display high-quality detail that we want it to, but because it's not necessary, it does not. Simply put, this is because what we are making is a prosthesis, not a nano-sized semiconductor chip. Then, What would be the width of the round margin observed by Gabriele? If I had to guess, I would say it is within several micrometers, which would put it in the range where no difference can be recognized clinically. Then, what is the range of preciseness that a milling machine can process? It may vary depending on the milling machine specification, but is known to be around 10 micrometers. In other words, a milling machine cannot reproduce a difference of several micrometers, and we cannot detect the difference in the prosthesis regardless of where we set a margin for the rounded areas. Additionally, this error is much smaller than the allowable 50 micrometer marginal gap suggested in prosthodontics textbooks and the allowable 100 micrometer gap in CID-CAM prosthesis. Therefore, although it may seem worrisome when viewed in greater detail, in reality, there is no need to worry at all. I still don't like the round shape. As we explained, although the round shape would not affect the final result, you may still be bothered by it. Maybe you just don't like it. So, we asked Medit if there was an option to increase image resolution, and they said yes. This means you can actually configure the settings to give you the display you want. This is like adjusting the resolution settings in a video game. It's totally optional. How can we see a clearer margin? Let's take a look at a video that goes through the process. Method number 1. Scan the margin area in HD mode. Make sure only that part is processed in high resolution. Method number 2. Draw margins. Make sure only that part is processed in high resolution. Method number 3. Adjust the resolution of the result in the settings. Watch the video for the method.
Let's start with the new features. High-resolution data processing uses Medit's AI technology to automatically detect prepared teeth for crowns and produces high-resolution data in the area. You can get high-resolution data without any additional manipulation and get sharper data than the previous version. Also, when a margin line is drawn, the selected areas of teeth with a margin can be processed at a higher resolution.
We all know that HD mode is recommended when scanning margin areas. The difference is that, as you can see on the screen now, the margin area is processed separately in high resolution. In the second method, we first set the margin we want to specify through the margin line creation function, and then it also goes through a separate high-resolution processing. The method 3 is what we covered in the last Please Solve Me session. If you change the default setting to high resolution in advance, the file size will be larger, but we will always be able to get clearer margins. In this way, you can see what you are familiar with. Let's go on to another concern in the question. Gabriele was worried about when a thick margin is formed horizontally, and if it changes to a rounded shape, where is the correct position to set the margin? We already mentioned that this round shape would not affect the result, but we still need to consider which margin type would be most suitable for the scanning process. Looking at other users' opinions, it was recommended to use vertical preparation, saying that the best way to overcome this issue is to just change the crown preparation method. Because in that way, we don't have to worry about horizontal discrepancy at all. In fact, in the case of vertical preparation, the position of the margin is set according to the surrounding gum height, so it is easier to set the margin position horizontally. This is an issue I really want to address, so I will cover at a later date in more detail with a separate question. This is the answer to question number 3.
I know we covered a lot of information today. I hope this all made sense. On the screen are question card about model's crown that we covered today with the answer keyword. We are glad to have learned a lot of new things while preparing for this session. Hopefully, what we covered today will improve your daily practice.